G'day everyone, how you doing? A quick video here on DeMoivre's theorem, which is the ability to take a fairly complex function, and make it easy to read, and the expansion of that or the modification of that becomes really easy in sys format. If we've got something like this, it's a rectangular coordinate raised to the power of 5. We could expand it out 5 times, multiply everything, tidy everything up. It's going to take a while. We don't want to do that. Okay? You could use Pascal's triangle to get your coefficients and work it that way. Again, fair bit in it. We don't want to do that. Let's look at a shortcut. Remember when we were doing some sys work before? We had Z1 and Z2, and if we multiplied them together, we ended up with this. We did have a bit of expansion of our sys part, and we eventually came to this. So really what we did is we multiplied the modulus and we added the argument. That's what effectively happened. And that's neat. So if we had z is equal to r cis theta, our standard one, and we wanted to work out z to the power of 5, notice I'm using the same idea here. Wouldn't it make sense to be able to convert this into sys format and then do something with that? Let's see where we go. Look, here we go. Z to the power of 5 equals r cis theta. Well, I'm going to make this one into a sys format. Now, if you're pretty quick, you should be able to see that's going to be square root of 2. 1 squared plus 1 squared is 2 square root of 2. Sys, because this is 1 and 1, we're in the first quadrant, 45 degrees, pi on 4. So usually the numbers here are pretty neat to get something like this out. So I'm going to put this in here. Z to the 5 equals root 2 cis pi on 4 to the power of 5. Now, this you might go, but I've still got to expand that out and play around with it, muck around with it and everything. No, you don't. Because look, when I did this, the R part of it came to the front. No, it's not 5. Not yet, because I haven't brought the 5 in. You're jumping ahead. EJ's already seen this. So, when I want to do this, see how the R's came to the front. So if I want to write a general rule for what might happen, wouldn't it be this? Z to the n equals, it's going to be R to the power of n. See how I multiply them together? But if they're the same, that'd just be r squared or r cubed or r to the 4. And with the angle part of it, I had to add them here. Well, if they were the same, if that was theta and theta, it'd just be 2 theta in there, wouldn't it? So wouldn't it be cis n theta? Can you see how this would work for me based on this idea here? So let's put it into this question. Z to the 5 would be equal to this one raised to the power of 5, cis 5 pi on 4. Let's expand out. This is going to be 4 root 2. Because the first 2 square roots will make 2, the second 2 square roots will make 2, making 4 root 2. And this is, well, I can leave it like that. That's okay. Let's leave it like that. Cis 5 pi on 4. Now, you might say, but hang on, the question was in rectangular format to start. Well, yes it was. From here, we can easily convert back. Remember what it looks like. Here we go. Cis 5 pi on 4. 4 pi on 4 is there. 5 pi on 4 is going to be somewhere down there. And it'll have a modulus of 4 root 2. So let's say it's there. This is going to be 4 root 2. And this here, because the whole thing is 5 pi on 4, that is 4 pi on 4, or just pi. That's going to be pi on 4. So then can't I just make myself a triangle right here? Right angle. Sine of pi on 4 is equal to the opposite over the hypotenuse. And cos pi on 4 is the adjacent over the hypotenuse. Let me just do one of them. You'll see the other one works the same. Sine of pi over 4 equals the opposite, I'll call this y, over the hypotenuse, 4 root 2. Sine pi on 4, you should remember that, that's going to be 1 over square root of 2. multiply this guy up, isn't it going to be 4 root 2 times 1 over square root of 2 equals y? Cancels. Y is going to equal 4. Now we've got to be careful. Got to be careful. Y equals 4. This distance equals 4. But when I'm looking on my graph, this is minus 4, isn't it? So actually the imaginary value is going to be minus 4. So let me get to my answer here. My imaginary value is going to be minus 4i. In a similar sort of way, cos is adjacent over hypotenuse. Well, the cos and sine of pi over 4 is the same, 1 over square root of 2. So this is going to work out exactly the same for my x dimension. And again, it's on this side, so it has to be negative. Okay? So my real part is going to be negative 4 as well. So what I've been able to do is I've been able to take this crazy guy. I don't need to expand it all out. I can change it into cis format, use the idea of DeMoivre's theorem, very quick to get here. I can plot it if I need to for the graphical representation of complex numbers, and then a quick little sine cos tan idea, and I can get my rectangular coordinate of this complex number expanded out. Alright, there's a lot in this. There's a lot in this. Complex numbers in polar, complex numbers in cis form, sorry, in rectangular, in polar format, DeMoivre's theorem, getting an answer in polar format, and then converting back into rectangular format. Lots in this video. I hope this one's helped. Catch you later.